In this experiment, you will be doing steam distillation of cloves to obtain clove oil, and then followed by separating the major components of the clove oil, which is eugenol and eugenol acetate as the major components. There are some other minor components, however. So as usual, there are going to be questions embedded in your pre-lab lecture. Please read your lab first before you try to answer the questions. Please pay attention to the video so that you can also answer the question carefully. And as always, remember you only have one shot at the question, so make it count. So what is this lab about? So as you've done in a previous lab where you've extracted nutmeg, you're also doing a natural product extraction. This is very important for organic and medicinal chemistry because a lot of things that we use as pharmaceuticals have some basis in natural products. And when we say natural product chemistry, we mean that these materials are derived from living organisms. In this case, you're going to have mixtures of compounds, as we saw in the previous lab, and then you're going to be separating them and purifying them so that these kinds of compounds could essentially be studied later. Like I mentioned before, they're the basis of many drugs, flavors, perfumes, cosmetics, and so on. In this lab specifically, a little bit different than the extraction of nutmeg is that we're going to get an oil, which we call an essential oil. It's the major component of the liquid that comes out of these materials that give it mostly its flavor, its smell, and essential oils are oftentimes used for a variety of medicinal chemistry purposes. And so this is true for our lab. Now, when you get into the lab, immediately get started because this extraction and steam distillation can take a very long time if you don't get ready. So I would say within the first 10 to 15 minutes of the lab, if you're not already set up and get everything going, you may run out of time. So you're going to make sure you have all the jacks you need in the hood. Make sure you have all the clamps, your ring stands, your heating mantles, anything you need to get started before maybe about 10 or 15 minutes into lab so that you're on time. You're going to need a 100 milliliter round bottom flask. You're going to get 10 grams of cloves, which are going to be in Ziploc bags right next to the balances. So each balance will have its own. You're going to need approximately 40 mils of water to start, but then also grab a beaker full of water. The water that you need to use is DI water, so please do not use regular tap water. So DI water only. And you're going to need foil from the foil box for keeping your distillation warm. So you need pieces of foil. It shouldn't be brand new pieces. You need the large pieces, but crushed up pieces because it's like a sweater. It's going to keep your reaction nice and warm. The room is often very cold, and so you want to also pull the sash down through the entire distillation, or you're probably going to also run out of time because your reaction will never get up to temperature. Each of your joints, please make sure that they're either lightly greased or you put a little water in the joints so that they don't freeze up. If they freeze up, you can't pull them apart, and you're going to be deducted points from the lab if you didn't follow instructions. So let's review a few things about distillation. So you've seen distillation before. Distillation is a separation technique. We could also use it as a purification technique. Separation and purification do not mean the same thing. Separation, we can separate things apart, but that doesn't mean that they're pure. In this case, we're using it as a separation. We're separating it away from the carbohydrates, etc., that's in the cloves. But we'll later do a purification. In some cases, like in Organic 1, when you separated ethanol and water, that's more of a purification because you're literally just separating two things and making them pure from each other and learning how to do that. So this is an excellent method for separating the volatile clove oil components from the other things that are in your mixture, and you can get relatively high yields. Now, different than regular distillation you've seen before, steam distillation is used to isolate a variety of organic compounds, in particular things like tars and oils and other liquids that are only slightly or not at all soluble in water. These natural products, we use steam distillation to get them um, because they're very hard to boil off naturally. They're very difficult to extract out of the component, like extract out of cloves. But because they don't dissolve in the water very readily, we actually can boil them off because they form, because they're slightly soluble. Almost everything is slightly soluble in water at high enough temperatures that we're going to boil our water off, and that water is going to carry the oil with it. Now, it's only going to be a little at a time as it's happening because, again, clove oil is not very soluble in water. And so we form what's called an azeotrope. It's something that the water and the oil are mixed together and they come off together. They don't separate apart. And the reason is clove oil actually has a much higher boiling point, so it's harder to remove. So by doing steam distillations, we've been able to discover a variety of compounds, but it's also considered mild because we're doing them at 100 degrees Celsius rather than very high temperatures. Higher temperatures oftentimes will cause things to degrade. And because they degrade, this is just a little bit slower than our body sorry, a little bit higher than body temperature. Body temperature, well, not a little bit higher, quite a bit higher than our body temperature, but not so high that it's going to degrade our materials. So that's why we can cook with these things and they don't degrade. But when you get higher and higher temperatures, they can start degrading. So if we are starting to go to 150, 200 degrees, they might start burning. And so steam distillation actually helps to prevent that. It helps to safeguard these compounds. And so you're just going to be boiling just like you learn in Gen Chem, water boils at 100 degrees. So when we do steam distillation, it may actually cause your boiling to be changed slightly, but not like dramatically. Majority, and that's why you have so much water in comparison to clove oil, majority of what's going to come off is water. And you're going to get a heterogeneous mixture when they boil off together. Heterogeneous means that it's going to be it's going to be clear that they're not perfectly mixed and your water is going to then look cloudy. And as your compound comes off, given enough time, they'll eventually separate from each other and you'll see an oil and then you'll see water. And so in your steam distillation, your setup is going to be, you're going to have a component where you're going to have a separatory funnel so that you can add more water because we want to keep our distillate constant. So we always must keep that level, whatever that level is. Once you put the cloves in there and you put your 40 mils of water in there, this must always be constant. This right here should be sealed off with a stopper so the separator funnel goes in the stopper, and you can put a stopper on here just to help keep it closed but not like tightly closed, or you don't have to put a stopper. It's not terribly important, but this should be closed off, otherwise the steam is going to just come out. And then on the other side, your as the steam from this comes out, it's going to go up. So you're going to register the temperature here once the steam comes up, and then as it starts cooling in your condenser, it will come and it will precipitate down. So here will be your water plus your clove oil. And so what's going to be important is that this thing is going to be very easy to start cooling down in your hood. So you're going to want to foil it, and you're going to want to foil it at this location. You don't need to foil anything past where your temperature is being read. So if you foil that, then you'll be reading the accurate temperature. And but you don't want to foil the condenser, otherwise you're not going to get condensate. And you can foil at this point. Now, what's in your water bath or your sand bath in this case it's a sand bath, will keep everything warm in here as long as your reaction is your mixture is in the sand. Some of you tend to put your stuff on the top of the sand, and if you do that, it's not going to heat evenly or correctly. We also want this to always, always, always have water. And this has happened only once since I've ever been teaching, but if you run out of water, the glassware can shatter. And the only way that you might be able to tell that it's shattered is that you might see this, uh, what looks like brown gas or just some sort of gas coming off from your setup, and it will start smelling really bad. So never let it run out of water. There should always be a level of water. So, by eye, or you can mark it off, you should have a level of water that never goes below where you started. Now, remember, this thing is going to be bubbling. So once it starts bubbling, that should probably be the marking point of how low it is. And here's what I mean by that. When it's not bubbling, it might be here. But once it starts bubbling, it might be bubbling and go up to here. Use that as your benchmark of how much water should be in there, because this is going to constantly be bubbling, and if it's constantly bubbling, you won't be able to tell the actual height of what's going on. So I'm going to erase this. The other thing to keep an eye on is that your thermometer needs to be somewhere in this general region so that it can no higher than this point right here, so that you can get an accurate-ish, it's not going to be perfect, it's going to be close to accurate temperature. And that temperature should be close to 100 degrees Celsius, and you want to make sure that you know what temperatures you're getting. Now, because it's probably cold in the room, you want to lower your sash. So this in reality is what it looks like. Again, this is sealed like I mentioned before. Your liquid is in here, and you can't see it, but your little cloves are in there, and the liquid will start turning kind of brown. You're going to put your thermometer on this side, and then you're going to have your distillate go on the other side. Now, once your distillate goes on this side, remember it needs to be in an ice bath so that it can collect easily. It will create a pressure to pull the liquid over. It will also allow the distillate to condense down into the flask. So you're going to use water with your stopcock to add water and keep your level correctly. Now, we do have some clamps to help you clamp everything together. Just make sure that they're returned if you need them. You may not need them. You may also have rubber bands if they're available. Sometimes the rubber bands disappear, so don't bank on them. All right, so in terms of the steam distillation, again, it's going to be two immiscible liquids, and they're going to co-distill with each other, the water and the clove oil. As you heat, the water and the clove oil molecules will come off together as a gas, so the water is basically dragging the clove oil over, and because it's low, we're going to be able to, it's a low boiling, you're not going to be destroying the clove oil too much. But the amount of water that we have allows your your liquid to be coming over easier, because we're going to get to the vapor pressure that allows water to come over, and the water is going to drag the clove oil over with it. And so once it hits the condenser, it will condense over. But thinking of Gen Chem, the pressure that your reaction is going to boil is going to be a consequence of the partial pressure, the vapor pressure that you need to boil water, and the vapor pressure that you need to boil the cloves. However, there's a lot more water, so it's going to be more like the pressure of the water. And so as you're it's going to cause your temperature to actually go up a little bit, so it's going to be higher than 100 degrees is the temperature you need, because you need to increase the pressure, the vapor pressure that you have. But you'll notice initially the water is clear, as mostly water is coming off, and then it starts getting cloudy as you get to a temperature in which the clove oil and water starts coming off, and you're going to keep adding water into your distillate to make sure that you don't run out of water. And so as you're heating, the boiling point will be a little bit higher than 100, but not terribly higher, right? And so you can monitor that temperature. You probably will get over 100 degrees. Depending on how cold it is in the lab, you might not notice it being too far over 100 degrees. So I've noticed that some people might see water boiling, what appears to be boiling to them, around 80, 90 degrees. In the lab, if their hood sash is not up, it's not down, and so you want to lower it so that you're getting a closer to accurate read. Also, if you're not foiled over, you might be reading the wrong temperature. So, like I said before, think of what you learned in Gen Chem, that you can actually figure out why the boiling point of the clove oil is going to be a little bit lower, and so you can use PV equals nRT to kind of figure out the ratio. You don't have as much clove oil, so the majority of what's leading the pressure and leading the boiling point is going to be that of water. And so we can figure out how much, that your pressure is more proportional to the water than it is proportional to the organic components. And so that's why instead of boiling point of clove oil, we're boiling at the boiling point of water. So again, same thing that I mentioned before. All right. So because we're mostly boiling off water, you don't have to put as much heat in to boil off the clove oil. So what essentially is in our clove oil? It's primarily eugenol and eugenol acetate, but there are other components. When you do your GC mass spec, expect that there might be 2 or 3 other things in there. Some people might only see 1 or 2. It depends on how well you do your extraction. And then when you do the lab, you'll notice that the room will smell like cloves. And if you are not careful, you might kind of get a little bit of that clove sensation inside your mouth if you're talking a lot in the lab. Clove oil is actually used in the manufacture of vanillin. You can get vanillin from vanilla beans, but it takes a lot more effort and more money. And it's used, clove oil is actually used as an antiseptic, especially in dentistry. If you ever have had your teeth removed or anything like that, and you've gotten an infection or something like that, oftentimes the dentist will use clove oil and put it in the wound, and it will help the wound heal, and it will also prevent, it will keep it clean essentially, and sometimes it will help with the pain. So like I said, periodically you're going to add about 5 mils or so of water to separatory funnel. It's going to cause your temperature to drop, and it's going to essentially cause the boiling to kind of cease for a second. And so that's why we add only 5, because we don't want the temperature to be dropped for too long if you add too much water. So if you add 10, 15, 20 mils of water, it's going to take a while for it to start boiling back again. And so once that happens, you might see water mostly coming out again, and then at some point the temperature might jump up again. Now, after you've been boiling for a while and you've gotten quite a bit material out, maybe like 40, 50 mils of water or liquid out, you might start noticing that the distillate only comes off clear at that point. That means all the clove oil I'm not going to say all, but majority of the clove oil has been distilled off with the water, and now it's just mostly water coming off. So after that, you're going to, if you have time, you're going to do the extraction, but if you run out of time, then you are going to need to do the remainder of this lab and next lab in one lab. So if you do, please label your stuff, put it in the community drawer. Now, be sure that before you leave, you have time to clean up. So the thing with the distillation is it's going to be hot. So you're probably going to need to give yourself 10, 15 minutes before the end of lab to make sure that you've had enough time for your distillate to cool. It will take a long time. So um, I would say maybe 15-20 minutes before the end of lab. If you're still not done, just stop and wrap up. If you didn't start on time, yes, you'll lose some points, but you don't want to go overtime on the lab. So when you're done, you're going to notice that your oil is going to go and eventually float on the top of the water, and that's because eugenol is less dense. The eugenol is less dense than water. Make sure that you get your molecular weights of your eugenol and your eugenol acetates into your notebook before you come back to lab. Make sure you look for what the boiling point of eugenol is before you come to lab. Um, Make sure that you complete any pre-lab work in your notebook before you come back to lab the previous week so that you can get ready to do everything. So what we're going to do in the second week, which we're going to go over in this pre-lab lecture now, is how are we going to separate clove oil? So basically, we're going to be using sodium hydroxide. You could also use potassium hydroxide, but in our lab, we're going to use sodium hydroxide, and we're going to do an acid-base reaction with the eugenol to separate it from the other components. So we're going to use DCM, dichloromethane, which has a density of 1.3-ish, which means that when it's mixed with water, it's going to be at the bottom.
This experiment, you'll be using ethyl acetate instead of dichloromethane because dichloromethane is a suspected carcinogen. Normally in these experiments, they normally have used dichloromethane, but because we want a greener experiment, we want to use safer chemicals in this experiment, we are going to be substituting for ethyl acetate. Now, ethyl acetate still has its hazards, but it's much less dangerous. It's so less dangerous. This is one of the chemicals that are used in nail polish remover. However, still be careful and cautious when using it. So any reference to dichloromethane in this video, please disregard and use ethyl acetate.
Now, eugenol is not water soluble, like I said, so it will mix with the dichloromethane. And because dichloromethane is going to be at the bottom, the clove oil is also going to be in the bottom when we do our extraction. Okay, so when you extract, you're going to expect the clove oil to the bottom. So you're going to get your separatory funnel, the 150 ml separatory funnel. If you don't have that size, you can borrow one from your instructor. More than likely you might have that, or you may have to split your separatory funnel mixtures in batches and do the extraction that way. And so you're going to add 15 mils of dichloromethane, and you're going to separate, and you're going to repeat this a couple of times. So what I mean by that is, because you're, and again, I'm not an artist, so that looks awful. You're going to get your two layers, the dichloromethane and your clove oil is going to be on the bottom, and your aqueous is going to be at the top. So this is where your water is going to be. So you're going to pull off the dichloromethane and your clove oil, and what you're left with is the water layer. So you're going to extract again with 50 mils of dichloromethane, and you're going to add the dichloromethane and the clove oil. And what we're doing is trying to ensure that we get all the clove oil out, because some of it will stick to the water a little bit. So once you've done that, now we're going to separate our clove oil material. So you're going to run a TLC first. And so as a reminder, you're going to get a TLC plate. Please don't touch the silica gel on the plate. You're going to spot with the clove oil, standard, and you're going to spot your extract. And you're going to run the TLC and see what that looks like. You should see multiple spots, but you want to record how many and get the RF values. And as a reminder, the F in RF is a subscript.